Good evening, ladies and gentlemen. We warmly welcome you all to the Green Talk conducted by the Green Building Council of Sri Lanka for the month of December. Sustainable development ensures that what we are doing now is better for us, but should also keep our future generations and the cycle should exist. The smarter use of natural resources will help our future generations, and green building are one of the example of sustainable development. As the Green Building Council of Sri Lanka, we always look forward to improve and promote the built environment with sustainable practices with the vision to transform Sri Lanka's construction industry with green building practices and to fully adopt sustainability as the means by which our environment flourishes, economy prospers, and society grows, ensuring the future well-being of our mother. So our monthly green talk on different topics will surely add something new to your knowledge. So today green talk topic is emerging pollutants, a bottleneck in sustainable water management. And the lecture will be conducted by Professor Thushara Chaminda. Let me introduce few minutes to Professor Thushara Chaminda. Professor Thushara Chaminda is a full professor in civil and environmental engineering at the Faculty of Engineering, University of Ruhuna, and he obtained his bachelor's degree in the field of civil engineering in 2022 from the University of Peradeniya and received his master's of engineering degree in 2005, specialized in environmental engineering and management from the Asian Institute of Technology, Bangkok, Thailand, and also he got his PhD from the University of Tokyo, Japan in the year 2008 in the field of urban environmental engineering. And Professor Thushara Chaminda has also won several international and local awards for his research achievements for last couple years, including Award for Asian Young Professional on Water Research in 2012 and Sri Lanka President's Award for Scientific Publication in year 2018. And furthermore, his primary research interests are in the water and environmental engineering with emphasis on emerging pollutant in urban water, antibiotic-resistant bacteria and PPCPs in water, groundwater pollution and treatments, sustainable water management, water quality modeling, air quality modeling, green technology for buildings and cities, etc. that have more than 1,000 citations. And also he has around 100 publications in international journal papers, book chapters, and international and local conferences. Last but not the least, according to the Edu World Scientist Ranking 2022, Professor Thushara Chaminda has been listed as #1 scientist in the field of engineering and technology at his current university, University of Ruhuna, and #5 scientist in the field of civil engineering in Sri Lanka. So I cordially invite Professor Thushara Chaminda to share his valuable knowledge and experience on this session. Dear sir, over to you.
Okay, thank you very much, Sudeep. Am I audible to you?
Yes, sir.
Okay. So let me share my screen, right? I hope that you can see my screen, right?
Yes.
Right, great. Yes, so this is a monthly talk organized by Sri Lanka Green Building Council under different topics. So they're organizing a talk relevant to the green buildings and sustainability and other, etc. But this topic might be a little different to you. But however, that I just thought of having this topic and having maybe discussion with you, because it's very important topic, although that not address or having a very good dialogue in Sri Lanka. So today that I'm going to talk on emerging pollutant, a bottleneck in sustainable water management, because you know that sustainable water management is a key component in any smart cities, sustainable cities, and sustainable buildings. So therefore, so we need to understand the limitations or maybe the challenges that we are facing while we are managing the water in the sustainable way. Right, okay. So, yeah, let me start in this way. Now, you remember the topic in the, I try to finish this within 45 minutes, so even less than that. So let me start. We know that our planet covered with water. So this is a satellite picture of our planet. So water, as you can see, it's a blue color because the water covers about 70% of our Earth crust, right? And we have a planet covered in water and with perfect solar power recycling taking place constantly. But however, we are facing water issues because as you know, if you think about all the water in planet is this, I mean the shown in this bubble, and these are the fresh water. So because 97 of the water in the world are saline water, or simply available in oceans, seas, lagoons, right? Estuary environment, right? With a lot of salty so that we cannot consume directly. So the fresh water are very limited, as you can see in this third bubble here, drop. So those are the readily available fresh water. But most of this fresh water are also trapped in North Pole and South Pole. Again, it is very difficult for us to use directly, right? So I think then I have used this diagram several times. So it's very simply say, if we assume that all the water in this world is 100 liter, right? 100 liter, just think that of course is more than that, but assume that all the water in this world is 100 liter. So the readily available fresh water that we can consume is less than half of the teaspoon. As a percentage is less than 0.003. So that is the reason that many people are saying that water is limited resources. And the problem is, it is not only the limited resource, its distribution in different part of the world also not uniform. Now, as example, you can see the per capita, that means the fresh water availability in the world. Per capita mean per person. Now here you can see these blue colors mean that countries having a lot of water. Blue color, light blue, dark blue. And these countries, especially Asia and Africa, we have less water, or simply you can say water stress or water vulnerable country, water scarce country. Even Sri Lanka is considered as water vulnerable country at the moment, not water stress country. So, but however, the engineers are, especially the water engineers, are in a different opinion. So they say, if managed sustainably and effectively, the planet's freshwater resources can meet the water demand of the world's growing population with good quality water. But however, we know the water scarcity and water quality degradation, and also the process challenges in securing enough good quality water to meet human and environmental and social and economic needs to support sustainable development in the countries. So the water scarcity is still there.
உனக்கு வேற ஒருத்தட்ட 40 கிராம் 50 கிராம் 30,000 மட்டும் பெரிய அமௌண்ட்ல 30,000 மட்டும் சின்ன கடனோட சுத்தி.
Can you mute, please? Right. So now we do understand so that we have issue with the water, especially the freshwater resources, right? So the water challenges are, becoming more urgent in the world, especially with the climate change impact and the population growth impact. So we already know that the greenhouse gases enhance the absorption and re-emitting of the infrared radiation, especially due to industrial activities and the vehicles and other things. So he basically human activity. So we are experiencing so-called global warming, right? So this, because of this global warming, right, reason this water and climate change are, linked together, right? They are strictly linked and more closely linked, and the impact of the climate change is having a significant impact on the world water supply. Now we know that water resources are limited, right? But because of the climate change, we are having that shifting of rainfall patterns and the water scarcity problem and water-related hazard and flood and drought, right? And also some areas we experience that increased frequency and magnitude of the extreme rainfall. In the other areas, we experience the droughts, right? And also the heat waves and the water pollution and many things that we are experiencing with the, we may experience with the climate change, right? And not only that, other thing is, other key factor is the population growth, right? Now the population growth, now here you can see, now we 15 November 2022 last year, right? Almost like 1 year before. So world population passed the 8 billion. Now here you can see the symbolic 8 billion baby born in Manila. Of course, there were many babies born in that day, but that she was considered as symbolic baby. And here you can see 2 pictures of 6 billion baby and the 7 billion baby. So the effect of population increase and the rapid urbanization is another problem that we are facing, right? Now here also you can see that most of the population are going to live. I mean, the increased population are going to, I mean, they are living in, they will be living in Asian, African countries, right? Now with this, now you understand, we have, the problem is, we have limited water resources, especially the fresh water, right? So we need to manage it. But however, now there are climate change influences as well as the population growth. It's not only the population growth, but the people want to migrate to the cities. That is another problem we are facing. Now, even at the moment, the world population dominated in the rural area, even now. But however, people want to migrate to the cities, right? So it is anticipated that urban population, especially in Asia, will be dominant compared to the rural population in future, right? Now the problem is, now engineers as well as the administrative people and all other people are, right, this politician even leaders, right, our leaders are responsible to provide necessary facilities or basic things for this grown population and urban population. But you know, the urban areas are very limited resources, limited water, everything's are limited, right? Especially the resources are limited, right? And now another problem that we are facing, I already told you that fresh water resources are limited, but now because of this urbanization, industrialization, right, we are experiencing now pollution, especially water pollution in many parts of the world. Right here, you can see some of the pictures, right? So the summary so far, the climate change and increased water demand through the population growth and the rapid urbanization have significant impact on the freshwater resources, right? So what we should do? That is the question, right? Now here also you can see another example. Now in Sri Lanka, right? Now if current climate change scenario continue and current population growth continue in Sri Lanka, by 2050, right? Sri Lanka will be now, at the moment, Sri Lanka is considered as water no stress country. But by 2050, within next 25 years, we will be considered as water stress country because the per capita freshwater availability, because at the moment, one Sri Lankan is having around 2,400 cubic meter per year. That means all of you are having 2,400 cubic meter per year everywhere. Right? I mean, that is all the water in this country. Simply taking all the water in the rivers, lakes, or even the rainfall, you take all the fresh water and divide by the population, that is the value, 2,400 roughly. So I think all the citizens in Sri Lanka should remember this value. All of you are having, you don't know where is it, but it is there, 2,400 cubic meter per year, right? But that value will be reduced by almost 1,000 by 2050. So it is 1,500. So that means we will be considered a water stress country. So think now we need to start manage our water in the sustainable way. Right. So this is not the way sustainable water usage. At the moment, what we are doing is we try to squeeze all the fresh water without considering our future generation. This is not a sustainable water usage. Right. So that's why, but still the engineers are in the different opinion. So they say, especially the water engineers, there is still no water scarcity. So is it a matter of management of water in a sustainable way, right? That means they say, if you manage water in this, available water in this planet, that you can do it. Because water is just a water is a cycle. Water move from different phases like solid to liquid and then gaseous water, and also water changes quality, but still H2O, H2O. That is their argument, right? So with this, however, so now the by 2050, as I already mentioned, there will be an 80% increase in water, 80% increase in the water, right? In the cities. And also demand for food will also increase up to 50 to 60% in future, right? Due to the increased global population, right? So therefore, out of the world 500 largest cities, 19% are predicted to have conflict with the rural areas over water. Because I told you now, because of the urbanization. Right? So there can be even water wars in the future. So there are some prediction and some philosophers or even some leaders are predicting that. Right? So therefore, with considering all those things, the United Nations came up with sustain, because why we are facing all these problems, right? Why people want to move to the urban cities? Why? Because they are developed, especially infrastructure facilities are much better. People can have more convenient, comfortable life in the urban areas, right? That means infrastructures, the buildings, roads, everything are there, more facilities, more technology, you can enjoy the life. So that is a reason, more convenient, right? But that the United Nations understood that is not just a development. So therefore, they set sustainable development goals to be achieved by 2030. I think you all know there are 17 sustainable development goals. So we call SDG. So all you should know this, SDG, right? Sustainable development goal. And out of this 17, number 6 is considered as clean water and sanitation, right? Now, as I am expertise in the environmental and water, so then I'm worried about this water, right? So I just talk about this water. So the clean water and sanitation. But however, this SDG 6 or Sustainable Development Goal 6, achieving the clean water and sanitation for all people, right? It is not alone. It means that collaboration among the cities and regions by sharing the best practices for rapid implementation is very important to cope up with this, providing clean water and sanitation and many other SDG. That means you can see here, the Sustainable Development Goal number 6, clean water and sanitation is interconnected with all others. Right. So with this understanding, right now, as I already mentioned, if I go back, right, the first message to you. Now, fresh water are limited, right? Fresh water are limited, but population are growing. People are migrating to the cities. Now, fresh water resources are very limited. Now, what we should do, right? So the United Nations set a target. We should achieve sustainable development goals by 2030, including number 6, clean water and sanitation. But 129 countries are not on track to have sustainable managed water resource by 2030. 20 countries, including Sri Lanka, right? So current rate of progress need to be double. That means we are not doing enough. So we have to increase the rate to achieve it. Otherwise, we cannot achieve it. Right. Now, how we can do it? We cannot rely on this fresh water anymore. Right. So that one of the best way that we can do is, of course, we can do the rainwater harvesting and different alternative water. And the other one is this reuse water or alternative waters are increasingly recognized as a potential new source of clean water for both potable and non-potable usage, right? That resulting in social, environmental, and economic benefits. That is sustainable development, right? So how we can do it? Of course, we can use alternative water, as I already mentioned, right? Maybe gray water. Gray water means the water from bathroom and laundry or washing clothes and also reclaimed water. Reclaimed water means the wastewater, treated wastewater. And rainwater, of course, the groundwater and other water, right? So then always in building sustainable, encouraged to use these alternative water other than treated water. When you use this water, now there is a bottleneck. That is my topic, right? So even right now, if you attended my lectures that as associate professional training program, I always encourage to use this alternative water, maybe treated wastewater or grey water, another thing. But now there's a bottleneck. That is what we call emerging pollutant. Emerging pollutant, right? So usually we don't address this part. So that's why I told you that in Sri Lanka, we don't have a dialogue, right? Among the, even no dialogue among the scientists or scientists to general public or administrative or political leader. But other countries, they do discuss this, right? So what are those emerging concerns? Pollutants or contaminants of emerging concern. Basically, we can divide them into 3 broad categories. 1, 2, 3 that I will explain you. Now, what are those? Those are chemical, right? That had not previously been detected. That means emergent, mean new type of, or less concentration. Most of these pollutants are available in very minor concentration, especially in the water environment, right? So those are called contaminants of emerging concern or simply emerging contaminant. So emerging contaminants are very important because the risk they pose to the human health as well as the environment is not yet full understood. That is the critical part here, right? Even though that even my lectures, I ask, okay, all the engineers, okay, you should use water reuse. Another thing, of course, that part is there, but we should understand the gravity. We should understand there is another side as well, right? So now what are those emerging contaminants? One is called endocrine disrupting compound that I will explain you. And other two, you know, pharmaceuticals. Pharmaceutical means simply the drugs that you use, right? Medicine, right? Including the paracetamol, antibiotic, those things. And others are personal care products, maybe shampoo, cosmetic, all those things. Now you may think, how come those things become polluted? Now that is a concern, right? Now let's think how these kind of, if you assume, at the moment we assume those are polluted, right? use them as pollutant, right? All right. So then how they may enter to the water? Now you can see in this picture, especially the medicine, drugs we consume, right? And from the hospital and other way, right? And also they enter to the wastewater treatment plant or maybe the septic tank, and then it may go to the groundwater, or from the wastewater treatment plant, after treatment, they may discharge, right? And then they water back and do the water treatment and at the treatment plant, and then provide back to the city, right? So that means it may come back to us, right? Okay. Now let me explain you. Now I told you, now you already know the emerging compounds are the chemicals that had not been previously detected or having the less concentration, right? And may cause some human health or environmental health issue, right? So basically they are EDC and then pharmaceutical and personal care product, right? Okay. Now, again, if I go back to the sustainable development goals, right? Now, the sustainable development goal, there are 17 sustainable development goals. And this number 6 is for clean water and sanitation. Clean water and sanitation, right? But you don't believe these emerging pollutants are addressed under other 2030 agendas of sustainable development goals as well, right? Even no poverty, there is emerging pollutant, target 1, right? And then number 3, number 12, number 15, right? So that is the situation now. It is not only directly under the clean water and sanitation, right? So that's why my topic told you, right? It is a bottleneck, right? So emerging pollutants can be understood in a broad sense as maybe some synthetic or naturally occurring chemical or any microorganism that is not commonly monitored or regulated in the environment, and also their potential impact, right? Or ecological impact is not widely understood. New pollutant, and their concentrations are maybe available in a very minor level, right? Okay. Now you understand the thing. Right. Now let me tell you, I already told you we can, categorize them into mainly 3. Right. First one is endocrine disrupting compound. What are those? So simply we call them EDCs. So where you can find them. And what are those? So those are chemicals or mixtures of chemicals that might interfere with our human body, or simply the body's hormone, hormones, right? Sometimes some of these chemicals act like hormone mimics. That means, they are not hormone, but if these chemicals enter to your body, they try to behave like hormone, but of course they are not hormone. That means they trick our body. They cheat our bodies into thinking that they are hormones, but actually they are not hormones, right? And on the other hand, and some of these chemicals block natural hormones from doing their job. So now you can understand how dangerous they are. Now, from where these chemicals are coming? So industrial chemicals and pesticide, and also some non-organic produce. Now, like even the the residues, and also some consumer product, household chemical, fabric treated with some chemicals, and cosmetic, some lotion, and also some fragrances, and some antibacterial soaps and others. That means the things that we are using day to day, right? And also some material used in the manufacturing process and transportation and the storage. Now you can see those chemicals are everywhere, right? And we don't do enough to control them because we don't understand them, right? And you can see that the danger. Now you can see from where they are coming, right? Even food, some lotions, some cosmetic, right? If they enter to our body, there can be several health impact, maybe obesity, diabetic, right? And some uh, like prostate cancers, breast cancers, and some allergy, asthma, inflammation, and so many health problems might be there. So this is one category, right? Okay. Now there are two more categories. Now I want to combine them and tell you the other two categories are pharmaceuticals and the personal care product. Now, if you combine them, we call them as PPCPs. Right. Now you know those things very well. Pharmaceuticals, simply the medicine that we get when you are sick, right? The products used by individual for personal health or even the agro business like farming also, right? So we use these drugs or medicine. The global consumption of drugs by human is more than 100,000 metric tons per year. 100,000, right? Now you can see pharmaceutical productions are increasing every day, every year. And the personal care products you use day to day, some cosmetic and sunscreen products, shampoo, inhaler, and all those things. Now you have to understand now, maybe at the end of this lecture, now scientists are considers those are as pollutant. Right. I will tell you why we need to worry about it. Right. Now here, you can understand the gravity of this problem. Now here you see the pharmaceutical trade around the world. Now, which countries produce more drugs? USA, Germany, Belgium, Switzerland, right? So those countries, especially US and Europe. And in Asia, of course, China, India, and Japan. And also Singapore. Right? Okay. And the global pharmaceutical market, right? It is predicted, the forecast to grow this pharmaceutical market by 7.7% within next 4 years. Now you can see to 2022 is going to be increased within just 4 years. Day by day, it is increasing. Right. This right now, ED I already talked with you, right? Now, actually, again, I am reminding you why we need to worry about this, because in buildings and the cities, we have reuse industrial wastewater because to rely on the fresh water. There's no enough fresh water. But when we are doing, we have to understand the hidden pollutant as well. They are not common pollutant as we are always talking, like nitrogen, phosphorus, calcium, hardness, right? Or COD, BOD. Not that those things. There are other things as well. Those are called emerging pollutants. Okay. PPCPs, pharmaceutical and personal care product that we use day to day, right? Gaining more increased attention as a class of emerging environmental contaminant worldwide, right? So you know that this medicine or drugs have specific mode of action and they are biologically active by design, right? And actually that the researchers says these pharmaceutical drugs are frequently found in the aquatic environment or water environment that usually in very low level, like nanogram to microgram level. Nanogram to microgram level, right? And on the other hand, they dissolve easily, but however, they don't evaporate in the normal temperature and the pressure. So they will remain in the water or environment in nanogram level or microgram level. So there can be some potential ecotoxicological and human toxicological concern, right? So pharmaceutical and personal care products are challenged for the urban water management as they are these physiochemical properties have a significant probability to, because we cannot remove them now, that is an issue from the normal treatment plant, right? And you know that when we take drugs, sometimes we take paracetamol, right? Maybe antibiotic, right? Maybe in milligram level, we know that. milligram level. But they are available in the environment is nanogram level. But however, sometimes this nanogram level, they might be available in, numbers are like 100. So even the small concentration, right, available in the large numbers, right? So their additive impact have still not been considered. That means the small concentration, 100 pharmaceutical products in one place, right? So we don't know the impact. So therefore, it is considered they are persistent. That means they are not easily removed by the typical water treatment plant or wastewater treatment plant. And they can be considered that the bioaccumulate product, right? Biological active and can impact to many aquatic organisms, especially fish and as well as the human, right? And there can be some toxicity impact as well, right? Now, here you can see this picture, how they come to the environment. Now, drugs. Of course, you use drugs, right? When you get sick, medicine, and please assured, not all these drugs or medicine absolutely. Maybe some drugs apply 80%, but some so, right? That means 20% will be removed from your body by the urine or feces, right? Through the wastewater. You can wastewater will come to the rivers and then ultimately sea, right? Why the pharmaceutical product present and rivers, right? Now you might have the question. Now this pharmaceutical and personal, because people use this, not very recently, more than 100 years, right? Maybe. So why have to worry? Because emerging means like still new. So why we have to worry now? The reason is the pharmaceutical and personal care products have probably been present in the water and the environment for as long one have used them, maybe 100 years. But we did not worry about it. Why? Because we did not know. Right? As example, in 1950s, 60s, why people, right? Of course, that production, that consumption was less, but still they were there in the water. But we could not detect. We could not detect because the technology was not that developed. But now the technology developed, analytical equipment developed, the knowledge has improved, right? So therefore, now we know their availability, right? In the large quantities, right? Okay. So are they really environmental pollutant? I just give you the one example. Now you can see in this picture, right? So they are called kind of vulture, right? One bird, right? So in 2004, it came as a surprise for the people and the scientists when unusual high death rate of this vulture, right? 3 species of this vulture in India and Pakistan, right? So when the scientists opened their dead bodies, and they found diclofenac. Diclofenac is, right, is a kind of painkiller, right? Like paracetamol or similar one, right? Diclofenac. So that was the reason for their death. Then scientists try to understand, because how come this chemical or this medicine, right, went to their body? And then it was understood that, this kind of type of birds, right, the vultures, they eat meat, right? This diclofenac is used in not only for human consumption, but it is also used in, right, agro business. I mean, the farming, the cattle industry, right? Cattle industry, beef industry, right? So these, the medicine remain in some part of meat, which has not been consumed, but maybe thrown away. So these birds have eaten these parts. That is the reason this medicine has gone to their body and reason for their death. So you can understand. So it's not very simple. So So there can be concern, so many concern, right here. Now you can see the United Nations regional group, at least 38 different pharmaceutical substances were found in everywhere, even in the surface water, groundwater, even in the tap water and drinking water as well, right? But so far, there's no standard currently exist for the PPCV compound. Of course, in the European Union have set the guideline for 10 nanogram per liter, and the USA have just 1 microgram liter. Japan is still considering. So there's no strict regulation standard because still the knowledge is not enough. Right. Now I'm going to give you another serious matter that we have to worry. That is what we call anti-resistant bacteria, antibiotic resistant bacteria, right? So now here you can see this Reuters news article says the rise of superbug, right? Okay, I will tell you what is this. Okay, now you know that all of you, almost all of you have consumed antibiotic. I don't think there's anybody here that there's I'm not sure that, but I believe that, right? Everybody have consumed antibiotic at least one time in your life, right? So what is the purpose of the antibiotic? Simply at bacteria. That means to kill bacteria, because when you are infected with the bacteria, you get cold, fever, and some other. So then if you go to meet a doctor, the doctor will prescribe you, okay, take this antibiotic. Now in country like Sri Lanka, right, without even doctor's prescription, we go to the pharmacy and take the antibiotic because we know maybe this might work for our sickness, right? Now, how much of antibiotic you take? Now, if you think, remember the capsule or this tablet, maybe 100 milligram, 150 milligram, right? But then I am telling you it is danger. Why? Now, this is the situation, right? Antibiotic, when you take the antibiotic, of course, it kills bacteria inside your body, right? Inside body. Because to kill these bacteria, you need high concentration like milligram level. But these antibiotics will now remove some of the remaining residuals will be removed from your body through urine and feces. And of course, remaining antibiotics, right? Now let's say the doctor prescribe you, okay, take 5 days, but maybe you finish it with 2 days and you are getting better, you feel better, and then you don't use them, and maybe you just throw away with this solid waste or with the garbage. Now those will be going to the environment. Now in the environment, they dissolve in the water or in the environment, maybe their concentration is very low. Now what happened? These bacteria will expose to this antibiotic in the environment, but their concentration is very low, like nanogram level. But you take to kill the bacteria who are inside your body in the milligram level. Right? So milligram level can kill the bacteria, but nanogram level, you can see milligram, microgram, nanogram. Nanogram level maybe not enough to kill the bacteria. Right? Of course, they can damage their cells, right? Some of the bacteria may be killed, but some of the bacteria may survive because it's a very low concentration, and with the low concentration, they are going to live in a long time. Now, what happened? Slowly, their antibiotic resistant genes develop, right? And then ultimately, what happened? There can be superbugs. It's like a Superman, right? So, who are the superbugs? Superbugs are resistant to all available antibiotics. Now you can understand the gravity, right? Superbugs are resistant to all available antibiotics, right? That means in case these superbugs come to your body, doctors cannot save you. Why? There's no medicine. Because he can survive under the any antibiotic medicine, any environment, because he's a superbug, right? So that is a danger, right? Now, this tuberculosis, right, kill 2 million per year. So there were several superbugs found in different parts of the world. So that is a danger, right? The reason is we just discharge, uncontrolled discharge, right? Or even without knowing or without understanding, or even we don't know the technique and we cannot do it, but they are coming to the environment available in the very low level, but that leads to develop antibiotic resistance. That is a danger, right? So reason for this antibiotic resistance are over prescription. Now, you know, even that this is there, even even in most of South Asian countries, the Asian countries, we are experiencing. And one thing is, maybe the doctors prescribe you, even you go and meet a doctor for viral infection, sometimes they prescribe you take antibiotic. The antibiotic cannot kill virus. It's for bacteria, right? So sometimes even you know that, okay, this might be good for me, and you just take this antibiotic without doctor's prescription, right? And we don't complete these antibiotic all, because that is why they say, okay, you use 5 days, you have to use 5 days. Otherwise, not all the bacteria. Now, the reason why they give you the 5 days, because they prescribe. So if you take the antibiotic within all 5 days, these antibiotic, the bacteria can be killed, right? But if you just use 3 days, and then some bacteria will be remain with the resistance. So that is the one thing, right? And also overuse of antibiotic, especially in the farming industry and other fish farming and other as well, right? Okay, and so danger here. Now this is the BBC article. Now you can see here the superbugs or antibiotic resistant bacteria can kill more than cancer by 2050. So that is the danger. Now you can see, now these are the death attributes, right? Now what cause more death? Now you can see, right? Cholera up to 120,000, right? The measles 130,000, right? Now also road traffic accident 1.2 million at the moment, and the diarrheal impact 1.4 million, and diabetic 1.5 million, and cancer 8.2 million. But in 2050, antibiotic resistant bacteria cause more than 10 million deaths. At the moment, it's 700,000, but 10 million. So this will be the number one in 2050. That is danger. Okay. Now here, I just want to show you the situation in Sri Lanka. I will just take another 5 to 10 minutes maximum, right? Now, this is how we did in Sri Lanka. Also, we did some research. Now, I'm not going to explain you this research and this experimental protocol and other thing, but I just want to tell you, we just check antibiotic resistance from some bacteria for the common 6 antibiotics in Sri Lanka, right? Now, here you can see, now we found that some resistance we found in almost all, for all the bacteria, right? But almost like more than 50 sometimes. Now here in this picture, you can see this is just assume like now here. Now, if you look at this picture, now here you can see some circle around this tablet, right? Here you can see circle. What that circle mean? This circle. But here you cannot find the circle, no. Right? This circle means now this all this within this petri dish in the gel media there are bacteria. So that means this tablet means antibiotic tablet. So that means this circle means this antibiotic can be right. This antibiotic tablet can kill the bacteria. But here no inhibition shown. No I mean the diameter or no outer diameter means they cannot kill the bacteria. That means the resistivity. Right. So just simply, I want to tell you the danger. Now, here, I want to show you, now in this example, in one of the wastewater we did in gold, you can see antibiotic resistance is 100%. No inhibition shown. You can see none of these tablet could kill the bacteria. So we have that danger in Sri Lanka. So we published several papers in Sri Lanka. some of the first ever papers in Sri Lanka regarding antibiotic resistivity, right? So we do have that danger. And also our research team found antibiotic resistant gene in Kalani River, right? So what we have to do now, future water management in Sri Lanka, especially man-made pollution, right? Of course, natural pollution that we can deal, but especially this agrochemical, industrial discharge, right? Heavy metal and some organic pollutant and PPCPs and other micropollutant, we have to have a serious concern and serious dialogue should be developed. Start, right? So what we can do, of course, in future direction, that is important thing. So future directions of continuous monitoring of wastewater treatment plant, rivers, and all these tributary for emerging pollution loads, right, are very important. But we don't do it. We just measure maybe some typical parameters. And treatment must be developed and implemented to control waste, because current wastewater treatment plant are not enough or not capable enough to treat these antibiotics or EDC or other pharmaceutical product, right? And also there should be proper waste collection system, including the used medicine and solid waste. And the strict rules and regulation policies should be there, right? Now, even some, maybe now you know that you go to the pharmacy, you can buy antibiotic by yourself. Of course, then in Sri Lanka, there are rules. Without prescription, doctor's prescription, you are not allowed to take some medicine except paracetamol and other thing. But we don't do it we don't follow that, right? So anyway, so there should be some mechanism to take back medicine by the pharmacies, especially in the developed countries, but we don't do. Now in the developed countries, they are doing it, right? But developing countries, we are not doing it, that unused, because we just throw away, right? And also the sustainable consumption of pharmaceutical also need to be promoted in order to reduce their loaded storage, right? And the awareness on environmental impact on these emerging pollutant for both consumers as well as the doctors and the pharmacies are also important, right? And also more research are needed, more research, right? And we need more data, right? Especially the research and data on the effect of pharmaceutical and on their ecosystem, as well as the human health and other things need to be developed, right? And also the analytical technique need to be developed, right? Especially in the freshwater and marine environmental and all other environment, we don't have that technique. But you know now, or at least that you understand, because of this COVID situation, to measure the virus, we need PCR. Everybody knows, right? But it's not easy, right? We don't have enough PCR. So we don't have enough equipment. So that need to be addressed. So the most important thing is there should be a dialogue among the scientists, university academies, as well as the general public. So that has already developed in other countries. There's a culture, but we don't have it at the moment. But I just want to tell you there's an alarming situation in Sri Lanka as well. So we need to start it thinking now onwards. Okay, thank you very much. That's all for this lecture. I hope that you get something out of today green talk, right? The important thing here, in the sustainable water management, we always encourage to reuse wastewater, industrial wastewater, but also we have to be very careful. There is an unknown part, right? Usually we don't address this, but you have to understand this is the unknown part that I reveal you today. Okay, thank you very much. So Deepa, over to you.
Thank you very much, sir. So, if you have any questions, now open to ask question for you.
Okay, seems no question.
I do have, Professor. Do we have any
Yes.
systems which can sort of treat even at a hospital or something, which we can see as of now, which has these capabilities?
Yes, actually, it's a very good question. I was expecting such a question. Yes, of course. Now we can do the treatment, right? Because now you know that they are available in minor concentration, and they usually they come to the environment through the wastewater or solid waste and other thing, right? Now, especially the wastewater, right? Now, typical wastewater treatment plants are not good enough to treat or remove these. Maybe less than 50% will be removed. But of course, that advanced technology like maybe even the ozonation, some other oxidation, absorption, or different high-tech filtration can remove it. Maybe it is believed like if you use some absorption, some material like even then carbon, right? Now I'm just telling you the carbon, right? I mean the activated carbon can remove because absorption. But problem is that is here very costly, especially for the lot of because the wastewater, I mean the huge amount of wastewater, right? It is not easy for us to effort, that technical knowledge, and that economically not feasible. That is one reason that even the developed countries are not doing it. So that is one reason. Of course, we can do it. But however, now country like Sri Lanka, rather than because you know that we don't treat wastewater properly because we are just doing the primary treatment in the septic tank. We don't have better even the secondary level treatment facilities. Right? So that is one reason. But as you ask question is very important, at least in the hospital wastewater. So we may be able to understand this and develop our wastewater treatment plant facility to treat in the maybe higher level. That is one thing. But on the other hand, this I believe personally, treatment should be, of course, that done, but the management in other way from the hospital and even the consumer level, the management is also important. Okay, any more questions? I hope that I answered your question, right?
Yes, yes, Professor. Thank you.
So there is one question in the chat box. What is the current mechanism in Sri Lanka for the disposal of drugs?
Yes, there is no, I mean, yes, that's a very good question. Now in the hospital wastewater, you know that the hospital, there are wastewater treatment plant, so they do the treatment. But again, I'm telling the same question is the typical treatment plant. The traditional treatment plants such as activated sludge system, that's not enough or the not I mean that technology is not good enough to remove all these drugs. That's the one thing. And now, but when it's come to the consumer level, that means, I mean, you and me, right? What we are doing with the remaining medicine, we just throw away, right? We just throw away. Now, in the some of the actually other European countries, the other thing, what do they practice? They just put in the toilet and just flush. I'm not sure that I don't think the Sri Lankans are doing it, but we just throw away with the garbage. And then it goes to the solid waste dumping slide, right? Maybe and through the leachate, again, it may come to the groundwater and as well as maybe the surface water. Of course, I did not show you the results. Now we found some of our groundwater, you mean the well water, are contaminated with this pharmaceutical product. We have published one paper in Galle area. Right. Groundwater contaminated. So we found that data. So we don't have proper mechanism at the moment. And the best thing is now one of the things that we should do with strict rules and regulations should be there, especially how to collect remain drugs. Of course, it's not that easy, but when we start it, right, maybe slowly we can do it. Right, everybody practice, okay, these remaining drugs, right, hand it over to some nearby place or some common places that where you can drop it, right, drop some unused medicine. So maybe if we have that culture in future, it's possible. But important thing is in the start proper dialogue, Okay. Thank you. Yes. There's another question. What are materials that can use to clean these drug impurities in the water? Yes. So some absorption like activated carbon can be used. Also oxidation can be used. But also I am telling you now, those are still under the research level. Right. Then some scientists says this, and I mean the absorption can remove to this level. Like it is found that maybe activated carbon process can remove maybe more than 90% of these remaining drugs, right? So now, yes, again, the same question. Now there are so many expired medicine in health sector. So I don't know actually what they are doing. I just believe they just throw it into the maybe with the garbage or maybe through wastewater. Right. So there's another question. Can microplastics also be considered as emergent pollutant in wastewater? Yeah, actually, yes, to some, but the microplastic is considered as basically micropollutant. Micro means that low level concentration. Yes, now some scientists consider the microplastic as emerging contaminants as well, but some do not. That's why I did not include the microplastic here. Because of course, the science are like this, the science are evaluating. Science are always changing. Now, today I am telling you that more than the microplastic, maybe the antibiotic is considered as the most danger at the moment. But maybe within next 10 years, it may change because of the scientific knowledge. But at the moment, right, as I already mentioned, the danger is there. I mean, because you can understand if antibiotic resistance bacteria can kill more than cancer. Now, with that prediction, you can understand the gravity. Right. What are the optimum methods to dispose the pharmaceutical at domestic level right now? Of course, the best mechanism is we have to I mean, there should be the government authority or private authority under the government. I mean, the observation. So there should be a mechanism to collect them. Because we cannot, in the domestic level, we cannot do the treatment. Domestic level, we cannot do. So that's the case. So that is the reason that we need to manage it well rather than. Yes, some water purification methods are available in the market at the moment. What are the comments about that? Some purification, yes, there are some, because as a professor in this field, I should not comment about this commercial available purification system, right? But there are some treatment, I mean, the filter units or treatment units that you can treat your water. But however, what I want to tell you, now, if you are drinking tap water from National Water Supply Drainage Board, you should not worry about it. Right? Of course, sometimes the turbidity level may high or maybe a little bit high chlorine. So then it is not a big issue. Of course, if you worry that you can use a normal filter, right? Because now there are some RO plant and other things. Maybe sometime it is not necessary. Of course, in some areas, if you are using the groundwater, which may have high hardness like calcium, magnesium, fluoride, maybe you may go for that option. Otherwise, you don't need to worry about it. But if you are using the filter, again, you have to be very careful, right? Now, some candle type filters, you have to clean them very well. Otherwise, there can be bacteria growth on the surface. Right? Now, we found some of the RO treatment plant in Hambantota district. The treated water contaminated with the bacteria. I mean, the influent water are not. I mean, the water coming to the filter are better, no bacteria, but the output water, I mean, the treated water may having bacteria. The reason was that they have not cleaned the filter. So that's the one problem. So yes, presentation, of course, that I can send you to the Green Building Council, so they will share with you. Right. But anyway, now this since somebody asked special Chatur asked that some water purification methods are available in the market at the moment. So yeah. But now since this question came, that I want to tell you now, in some areas, right, especially in the rural areas, now there are some maybe I don't know, people especially try to sell these filter or their purification method by cheating rural people, cheating, right? So don't trap for those things. Because now I know this should be a different I mean the discussion, but however now you have to understand, maybe we don't drink pure H2O. We don't need it. And there's a, I mean the water is H2O, but we never drink H2O. I don't think that any of you have tried H2O. We just drink water. That drinking water include H2O mainly, plus other minerals, calcium, magnesium, fluoride, which is needed for our, our body, right? Because these guys, for their commercial purpose, they have gone to these rural areas and then use this tap water, ground water, and then add some chemicals, and then try to precipitate this calcium basically, and magnesium or other things, and show, okay, see this, your water might have contaminated, that's why this black color part, or maybe this brown color. Actually, there was also calcium and other things. Of course, it is there, right? And they also take their water, right? They might have taken their water in one bottle, maybe, this battery water, right? Some people know battery water is a pure H2O. Deionized water, no iron. So they use that water, right, added to their system and say, okay, in this water we don't have, right? So be careful. I mean, if somebody come and especially come to your home or villages or your relative places, right, and then try to sell this kind of thing, right, don't buy it. So there are some cheating going on. I know it personally. I have told several times to the government authorities and other people. I'm not sure whether, because I am just a professor, but we know it's cheating, but we cannot take the action, but it's going on. Right. Okay, any more question?
Can this residues like antibiotic or hormonal things and all those things can be removed with our Sri Lankan water purification system, or will they still remain in the water system after the purification?
Yes, actually, I already answered, but the thing, we cannot do it from our traditional treatment plant. We cannot. Maybe 50% you cannot, but 50% might remain. So that's why our research, I told you already, right? We found that wastewater treatment plant, we found antibiotics, right? Relatively high concentration antibiotic, actually, and also antibiotic resistance bacteria in wastewater. And actually, this antibiotic resistant ratio we found in Sri Lanka is a little bit higher than India and some of the Asian countries. So that means that our treatment plants are not capable enough to remove it. That is true. Because those treatment plants are designed to remove that traditional, especially the carbon, nitrogen, phosphorus, sulfur, right? All those pollutants or BOD, right? Those things. Not to treat these micro-pollutant or emerging pollutant. It is similar in the other countries as well, even the developed countries, because it's very expensive now to having these, that all those actuators, the actuated carbon system, ozonation, no RO is very, very difficult. So in the large treatment in the large quantities, right? It needs a lot of money and a lot of technology, and especially a lot of energy as well. So anyway, now this is the science because these are new things, right? Don't worry about it because these scientists, that's why I told you. Now, of course, we found it very recently, especially last 20 years, but these chemicals were in the environment since we humans start using them, right? The thing all that we did not know because our analytical capability was very less those days. We could not detect them. But now, because of the technology, we can detect. That is the reason. Even in future that we may find maybe different type of other pollutant as well. So anyway, those are called emerging pollutants. So new pollutants, new contaminants that we don't know much, right? Now, what I just told you is a very limited knowledge. I just try to summarize with my experience in Sri Lanka and other countries and reviewing just is not. But there can be, I mean, there are so many things that we should know about these things, right? When scientists understood fully, so maybe in future that engineers may develop new technology or new simple technology to remove it. At the moment, people try to understand their availability. Other thing. Now, even what I did was, now, this research and everything is like that. First, any pollutant, we have to understand whether they are available in the environment and their concentration level, their property. That's the first step. After you understand that their concentration, their properties, then engineers try to remove them. That is second step. Now, still in the many countries, we are still in the first level. Understanding and identify their properties and their quantities, the concentration level and other. That is what we are doing even in Sri Lanka at the moment, even in many Asian countries. But the developed countries are now have gone to the second level. They try to improve the develop the treatment technologies. Right. I hope that in future we may get good simple technology that maybe we can even implement in Sri Lanka as well. Okay. Yeah. Rainwater may have less antibiotic pollution. Yes, that's true. If you can capture the rainwater directly, yes, very correct. Right. Okay, Sadeepa.
Okay, thank you very much, sir, for conducting highly inspiring session and taking time from your busy schedule to be the resource person to this green talk and sharing your valuable knowledge for us. And sir, your constant guidance and contribution, which certainly takes DBCSL to new height. So thank you again very much, sir. And as well as thank you all for being a great audience today's session. And thank you again all. And good night. Let's meet up with our next green talk. Thank you all.
Okay. Thank you, Sadhu. I will share this PDF of this lecture, so then you can share with the participant, right?
Okay, sir. Okay.
Thank you and good night, all of you.
Thank you, sir.
Okay.
Thank you very much, sir.